Yeah, good morning to one and all. Myself, Shubhamsir, your master teacher. So, how are you all, guys? I hope you are doing well and good at your home. Say yes or no. Just give me thumbs up. Just tell me yes or no. I'm starting the hotspot. Just tell me yes or no. Yeah. Hi, Vaibhavi. Hi, Tushar. Hi, Kunal. Hi, Trusty. Hi. So, I'm handing the hotspot. Five, four, three, two, one. If you are unable to see me and listen me, just refresh. Okay. So we are going to start today's topic. What is today's topic? Today's topic is number system. Okay, we are going to see each and everything in detail. Number system. I hope it is clear to each and everyone. We have studied earlier also. What is number system? Types of numbers. Yeah, just tell me in the chat box. Have you seen it? Have you learned before in the previous classes? Yes, we have learned. Yeah. So what is the roadmap of today? Today's roadmap is introduction to numbers, properties of rational numbers, representation on number line, rational numbers between two rational numbers. Then we are going to see divisibility test. Okay. Then after we are going to find out HCF and LCM. Okay. This is the roadmap for this particular topic, number system. Yeah. Here to all. Yeah. Fine. Just give me a thumbs up in the chat box fast. Okay. Well. Good. Yeah. So starting with introduction to numbers. Introduction to numbers. So just before starting introduction to numbers, just recall the definitions which we have learned on previous classes. Have you learned something in previous classes? Types of numbers. Yeah, just type in the chat box what you have studied in the previous classes. Yeah, yeah, very good, Vaibhavi, very good. Yeah. What about others? Just type in the chat box fast. Yeah, you're doing very awesome. Okay, good. Types of numbers. What are different types of numbers? The first one is natural number. The second one, whole numbers. Third one are the integers. Fourth one are the rational numbers. Okay, these are the types of numbers which we are going to discuss in detail. Okay, starting with natural numbers. Natural numbers are those that are used for counting and ordering. Okay, they are starting from 1, 2, 3, 4, and so on. Okay, numbers starting from 1, 2, 3, 4, 5, and so on are known as natural numbers. Okay, and what is the symbol used to represent the natural numbers? Symbol N is used to represent the natural numbers. Okay, just make it more clear. We use symbol N, alphabet N to use or to denote natural numbers. One more important thing, have you seen something? What is written below? Zero. Zero is not a natural number. Zero is not a natural number. So what is zero? Can you tell me? Just write the answer in the chat box. Fast. Everyone, fast. Yeah. Very good. Zero is not a natural number. What is zero? Zero is a whole number. So our next topic is whole numbers. So what are whole numbers? All the natural numbers along with zero are known as whole numbers. All the numbers starting with zero are known as whole numbers. Okay, the numbers starting from 0, 1, 2, 3, 4, 5 till infinity are known as whole numbers. And by which symbol or by which alphabet you are going to represent the whole numbers? W, alphabet W. Anybody is having any doubt in this? Just tell me yes or no. I'm starting the hotspot. Tell me yes or no. Okay. Anybody is having any doubt? It is clear to each and everyone. I'm ending the hotspot in 5, 4, 3, 2, 1. Okay. Now moving on the next one. What is the next one? Tell me. The next one is integers. So what are integers? These are the set of whole numbers including the negatives. Means positive numbers, negative numbers, as well as zero. are known as integers. Once again, what are integers? Negative numbers, positive numbers, as well as 0 are known as integers. And what is the symbol used to represent the integers? Z. We use capital Z to represent integers. Clear to each and everyone? Say clear? Yeah, very good, fine. Anybody's having any doubt? Excellent. Good job, Prabhavi, good job. Yeah. Next one, rational numbers. What are rational numbers? Numbers in the form of P by Q. But what is the important condition? Q must not be equal to 0. Q must not be equal to 0, guys. Where P and Q are integers, therefore it is known as rational numbers. Example, 2 by 3, 1 by 4, 9 by 8. Okay, these are the examples. So can negative numbers be the example of whole rational numbers? Yes. Minus 4 by 5 or minus 2 by 3. Next example, minus 1 by 1 is also a rational number. Clear to each and everyone? These are the examples of rational numbers also. This can be negative also. They can be negative also. Yes, they can be negative also. Clear? But what is the condition? Q must not be equal to 0. Q must not be equal to 0. Clear? Anybody is having any doubt in this? A fast recap. What we have learned? We have learned what are natural numbers, what are whole numbers, what are integers, what are rational numbers. Clear? Clear to each and everyone? Yeah. Okay. Very good. Let us see by using a Venn diagram. Okay. Natural numbers. All natural numbers are including in whole numbers. All natural numbers are including in whole numbers. Okay. All natural numbers are including in whole numbers, and all whole numbers are including in integers. Okay. All whole numbers are including in integers. Okay. So set of natural numbers is contained in a set of whole numbers. Clear? And set of whole numbers is contained in integers. Clear? Venn diagram is clear to each and everyone? Okay. Fine. So here's your favorite activity. We're going to see by using a question. Okay, we're going to solve a question. Yeah. Here comes your first question. Which of the following statement is true? Just tell me. -1 is a rational number or not? -1 is a rational number? Question number 2. Every whole number is contained in a set of integers. And question number 3. What is question number 3? Every number is in the form of P by Q is a rational number. So just think and tell me what is your answer. Okay, just take your time and tell me the answer. Okay, we are going to discuss it. Okay, take your time. Okay, yeah, no need to write in the chat box answer. Okay, just solve by your own. Okay, just think and tell me the answer. Okay, yeah, can we start? Okay, fine. Yes, -1 is a rational number which can be written as -1 by 1. Okay, this can be written as -1 by 1. Say yes or no. -1 by 1 is a rational number. Yes, it is a rational number. Okay, and Q is not equal to 0. Therefore, condition satisfies. Therefore, -1 is a rational number. Clear? Okay, excellent. Every whole number is contained in a set of integers. Yes. What are integers? Integers are positive numbers, negative numbers, as well as 0. So whole numbers are, we can say that, what we can say, every whole number is contained in a set of integer. Okay. Now the third question. Every number in the form of P by Q is a rational number. Tell me fast. What is the third question? Every number in the form of every number in the form of P by Q is a rational number? No. What is the condition? The condition is q must not be equal to 0. If q becomes 0, then it will not be a rational number. Clear? Anybody is having any doubt? Sir, why p by q is not a rational number? See, what we have studied, see, what we have studied, what is the definition of rational numbers? Here's the definition of rational numbers. What is the condition? Q must not be equal to 0. This is the definition. So by using this definition, what condition satisfies? In place of q, the denominator must not be equal to 0. Therefore, every number will not be a rational number unless and until q is 0. When q is 0, then it will not be a rational number. So the answer of this question is false. Clear? If the question says q is not equal to 0, then this question will become true. But it is not mentioned in the question that q is 0 or not. Therefore, the answer is false. Clear to each and everyone? Yeah, okay, very good. Now, here comes your favorite activity, quiz time. Are you ready? Just tell me, just type in the chat box, are you ready for the quiz or not? Say yes or no. Guys, just type yes or no. Are you ready? I'm starting the hotspot for this. Okay, just tell me yes or no. Okay, are you ready for the quiz? It's quiz time for you all. Just say yes or no. Ending the hotspot in 5, 4, 3, 2, 1. Here we go. Okay, what is the first question here on your screen right now? Number R is termed as a rational number if it can be represented as P by Q. But what is the condition? If R is known as a rational number, what is the condition? Just tell me. Yeah, just tell me what is the condition. Which of the following answer is correct? Just write your answer in the chat box fast. Which of the following option is correct? Where A, what is option number A? P is equals to 0. What is option number B? P is not equals to 0. What is option number C? Q equals to 0. And what is option number D? Q not equals to 0. Yeah, start the quiz. Okay, I'm starting the quiz. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Excellent. Good job. Yeah, so what's your answer? Yeah, very good. We have already studied what is the definition of rational number. The definition of rational number is the numbers which are represented in the form of P by Q, and Q must not be equal to 0. Excellent job. Excellent to each and everyone. Thumbs up. Very good. Very well performance, each and everyone. Now, next question. Are you ready for the next one? Here comes your next question. Which of the following statement is false? Which of the following statement is false? Point number A, every rational number is a fraction number. Yeah, options are fraction numbers are always positive, 0 is a rational number or not, or all of this. Which of the following is false? Okay, take your time and tell me the answer. Okay, take your time and tell me the answer. Which of the following statement is false? Yeah, it is very easy. Every rational number is a fraction number. Natural numbers are always positive. 0 is a rational number or not. All of this. Okay, just tell me which of the following numbers, which of the following statement is false. Okay. Completed? Just tell me yes or no fast. Okay, here we go. What is the answer? Which of the following statement is false? Rational numbers are always positive. We have already seen in our previous slide that natural numbers can be negative also. Remember, natural numbers can be negative. For example, minus 1 by 1. Then minus 2 by 3. Minus 5 by 7. This all can be rational numbers. So rational numbers can be negative also. Clear? Clear to each and everyone? Okay. Which of the following statement is false? Rational numbers are always positive. This statement is false. Clear? Thumbs up. Okay. And what is the answer given? Rational numbers can be negative also. Yeah, here it is also written the same thing. Okay, rational numbers can be negative numbers also. So moving on, next one. Decimal representation of rational numbers. Decimal representation of rational numbers. Let's convert some of the following numbers which are in the form of p by q into decimal form. Are you ready with this? Okay, fine. So 1 by 8. How to solve 1 by 8? How to represent 1 by 8? Just solve by dividing. See, 1 by 8. 1 is smaller. When the numerator is smaller than the denominator, what we used to take? We used to take a decimal. What we have taken? We have taken a decimal. Clear? We have taken a decimal. So it becomes 10. 8 ones are 8. What is the remainder? Remainder is 2. Then carry on again 0. We'll carry forward. Then 8 2s are 16. What is the remainder? 4. 0 will come because it is in the decimal. 8 5 are 40. So what is the answer? 0.125 is the answer of 1 by 8. On converting 1 by 8, we are getting 0.125. Clear? Say yes or no. Anybody is having any doubt? Just tell me. I'm starting the hotspot. Just tell me. Okay, fine. Anybody is having any doubt in this? Okay, can we move to the next one? Okay. As the remainder is 0, we already know that the remainder is 0. And what is the answer? On converting 1 by 8, answer is 0.125. Okay. Now, next question. How to represent 2 by 3? How to represent 2 by 3 in decimal form? Okay. Here again, the numerator is smaller than the denominator. So we have to take point. Okay. See, on taking the point, it will become 2 will become 20. 3 6 are 18. Now what is the remainder? 2 is the remainder. 0 will come. It will become 20. Again 3 6 are 18. Again remainder is 2. 0 will come. Again 3 6 are 18, and so on. Have you noted some difference in the previous question and this question? It is not ending, and remainder is coming each and every case. Clear? So the remainder is not going to be 0, and 6 is repeating infinite times. So what is the representation of 2 by 3? 2 by 3 can be represented as 0.6666 and so on. Okay. Clear? Anybody is having any doubt? Clear to all? Okay. In this, the remainder is not 0. Okay. And you have to write like this, 0.66666. Okay. Here, what 3 dot represent? The 3 dot represent that the number is not ending. It is going continuously. Okay. The 3 dot represent the number is not ending. It is going continuously. Clear? Next question. What we have observed? Tell me what we have observed. When we convert the rational numbers into decimal forms, there are two types of cases. What are two types of cases? Either the remainder will become 0. Okay, and when the remainder becomes 0, it is known as terminating decimal. Okay, what is terminating decimal? See, just see once again. Here, when the remainder is 0, terminating decimal means terminating remainder. See, terminating quotient. Whenever the remainder is 0, clear, whenever the remainder is 0, terminating decimal. Clear, the decimal does not expand. See, not recurring, not repeating. It is ending in 0.125. Clear? And what is the next one? Remainder never becomes 0. When the remainder never becomes 0, it is either non-terminating, repeating, or recurring. Okay. It means, see this example. The remainder is not 0, And what is the quotient? The quotient is continuously repeating. So decimal number in this is continuously repeating. And what is the other word? Recurring. Clear? Just see once again, have this. When the remainder becomes 0, it is known as terminating decimal. And when the remainder is not 0, then it is known as non-terminating, repeating or recurring decimal. Clear? Yes. Excellent. Now, let us take some other examples. 1 by 50. We know that 1 by 5, 1 by 5, and 1 by 50. Here, 13 by 16. What is the answer of 1 by 50? 0.02. 0.02 is the answer. It is terminating. Terminating means ending. Khatam ho raha hai yahan pe. Clear? 13 by 16. On dividing 13 by 16, what we are getting? 0.8125. It is also known as terminating. That means it is ending. Next example, 2 by 15. See, 2 by 15. It is non-terminating repeating. Non-terminating repeating means it is not ending, and 3 is repeating in this. See, have you seen in this? 3 is going to repeat again and again and again, and it is not ending. So what is the definition? Non-terminating and repeating. It is a non-terminating and repeating example. 125 by 9. On dividing 125 by 9, what we are going to get? 13.8888 and so on. Here, it is not going to be end. It is non-terminating. And what is repeating? The number 8 is repeating. Clear? Anybody is having any doubt? Terminating means ending. Okay, I'm going to write here what is terminating? Ending. Okay. Clear? And what is non-terminating? I'm going to write here non-terminating means not ending. Okay. Anybody is having any doubt? Clear? Okay, excellent. Now, let's solve. Let us see by using some another question. Okay. Write 1 by 11 in decimal form and say what kind of decimal expansion it is. Okay, you have to write and tell me. What you have to tell, whether it is terminating or non-terminating decimal. Clear? You have to tell whether it is terminating or non-terminating. Yeah, take your time and solve. Okay, just divide 1 by 11. Okay, take your time. Yeah, and tell me whether it is a terminating decimal type or non-terminating decimal type. Okay, just tell me. Okay, I'm starting the hotspot. Just tell me, have you solved or not? Okay, I'm starting the hotspot. Take your time. Yeah, no need to write in the chat box. Just solve, okay, and tell me yes or no. I'm ending the hotspot in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here we go. So can we start the solution? Okay. See, on dividing 1 by 11, see, 1 is numerator is less than the denominator. So what we are going to take? We are going to take point decimal. Okay. So on solving, okay, on solving, see what it comes 10, and on solving, what is the answer? The answer will come in the question. What is the question? 0.090909. It means it is non-terminating and repeating. See, remainder is coming in the last. Remainder is coming. So it is non-terminating, repeating, non-terminating and repeating. Clear? It is non-terminating and repeating one. Clear to each and everyone? So which type? What is the answer of this one? The answer of this one is, the answer is, it is a non-terminating, repeating type decimal. It is a non-terminating and It is a non-terminating and repeating type decimal. C, it is repeating 0.0909090. Okay. So 1/11 is a non-terminating and repeating type decimal. Clear? Clear to each and everyone? Okay. Now, 7/2 in the decimal form, and tell me whether which kind of decimal it is, terminating or non-terminating. Yeah, you have to do the same thing. You have to check by dividing. There's not any shortcut method. Okay. I will tell you there is shortcut method also, but we're going to discuss. Okay. By seeing the denominator also, we can identify whether it is terminating or non-terminating. Okay. But just check. First of all, we are making the base foundation. Okay. Just tell me on dividing. I will give you a hint, but without solving. It is a terminating. Okay. But how? You have to tell me what is the question in this. Have you solved? Take your time. Take your time. Solve, everyone. Yeah. Completed? Excellent. So what is the answer? On dividing 7/2, we are getting 3.5. Yeah, I've told you it is a terminating one. Terminating one, 3.5. So decimal expansion is terminating. Okay. 7/2 is of which type? It is of terminating type of decimal. Clear? Clear to all? Anybody is having any doubt? What we have discussed today? We have discussed this one. We have discussed what we discussed this one. Terminating, which of the following are terminating, which of the following are non-terminating, and repeating ones. Okay. Clear? Okay. Now tell me, anybody is having any doubt? Anybody is having any doubt? Just tell me. Okay, no doubt. Funda clear. Very good. Excellent. No, sir, no doubt. Very good. Very good. Yeah. So can we take some more questions? Okay. We are going to start your favorite activity, quiz activity once again. Here, which of the following has terminating decimal expansion? Which of the following has terminating decimal expansion? What are the options? Option number A, 1/7. Option number B, 1/3. Option number C, 3/5. Option number D, 17/3. Which of the following has terminating decimal expansion? Which of the following has terminating decimal expansion? Tell me fast. Which of the following has terminating decimal expansion? Take your time. Yeah, it is very simple. What we have to do, you have to just divide and check. Is there any other method? Yeah, there is any other method also. I will going to tell you. Just solve this one. Okay, time's up. The answer is 3/5. Okay, why 3/5? Here is your hint. Hint is whenever the denominator is in the form or in the multiple of, or you can say that in the multiple of 2 or 5. In the form of 2 or 5. Multiple will be wrong. In the form of 2 or 5. In the form of 2 to the power n or 2 to the power n. Okay. 2 or 5. The base will be either in the form of 2 or 5. So it will be a terminating. So it will be what type? It will be a terminating type. It will be a terminating type. Clear? It will be a terminating type. It will be a terminating type. Clear to each and everyone? Clear? So whenever the denominator is in the form of 2 to the power n or 5 to the power n, it will be a terminating type. Here, the decimal is 5. The decimal is 5. Sorry, the decimal not. The denominator is 5. Okay. The denominator is 5. So we can say that it is a terminating type. So what is the hint? Here is the hint. This is your hint. Okay. This is your hint. Whenever the denominator is in the form of 2 to the power n or 5 to the power m, okay, not a multiple in the power. Okay. So it will be a terminating type. Okay. Or you can check simply by dividing also. 3 by 5 is coming 0.6. It's the terminating decimal expansion, and all others have non-terminating representation. Therefore, option number C is correct. Clear? Next one. 2 by 15. On dividing 2 by 15, we are going to get 0.133333. Sir, how much times we have to write 33333? There is something shortcut method or other method to represent this? Yes, you can represent like this. Bar. Have you seen something? Bar over 3? Yeah, this is the bar. This is the bar. Okay, this is the bar. So you can write 0.13333 as 0.13. This is also correct. Clear? This is also correct. Clear? So this is another method where it is known as 3 of bar. Okay, where 3 is repeating infinite number of times. Clear? Clear to all? Well done. Okay. Next one. 125 by 9. What is the answer? 13.8888. So we can write as 13.8 bar. 13.8 bar. Okay, no need to write like this. Just write like this. Okay, 13.8 bar. Okay, this is the most technical method to represent the decimal expansion. Okay, 0.13 bar. And what is the answer of this one? 13.8 bar. Clear? Anybody is having any doubt? Just tell me yes or no. I hope it is clear to all. Okay. There is any quick method to find out whether the given rational number is terminating or non-terminating? We have already discussed. Okay. I'm giving you once again the hint. Yeah, a fraction p by q is terminating decimal only when the prime factors of denominator are 2 or 5 or in the form of 2 to the power m or 5 to the power n. We have already discussed this. Okay. See, the denominator is in the form of 2 to the power n, 5 to the power n. It is terminating. Okay. Here 16 can be written as 2 to the power 4. It is terminating decimal. And on the examples of non-terminating, for example, 2 by 15. See, here it comes 5 and 3. 3 is extra. In denominator, we want only 2 to the power n or 5 to the power m, not extra, only this much. Okay, 2 to the power n or 5 to the power m. Clear? Only this much. Other than that, it will be not considerable. Clear? Anybody is having any doubt? Okay. Thank you so much. This for today only. Thank you so much. Okay. Have a nice day to all. Yeah.